So let us start with the question number 10. So here the question given is that let G be a cyclic group of order 2023, that is 2023, then the number of subgroups of G including the trivial and the whole group is how much, right? Okay, so first let us write down, it is given that 2023, right? Now this 2023 can be written as in this form, that is 7 into 17 square, correct? Now, so number of divisors, how many number of divisors are there? That is 1 plus 1 into 2 plus 1, correct? So that means the subgroups here, including the number, a whole number itself will be 1 plus 1, that is 2 into 3, that is 6. So here the answer should be 6. That is option C. Okay. Next question. The next question, there it's given that the sum of all the 3-digit positive numbers which are divisible by 7 but not by 14. Okay. So we have to find out the sum of a series. So first we have to form the series, right? So what are that we are given? We are given 3 digits, 3-digit number divisible by 7, not divisible by 14. So the smallest 3-digit number divisible by 17 but not by 14 is actually 105. Okay. Now we have to form, let's say, a AP series. Okay, where I'm going to take the difference as 14. So the next term after 105 will be plus 14, so that is 119, and so on, such that the largest 3-digit number divisible by 7 not by 14 will be 987. So this is our AP series with D is equals to 14. Now in order to find out the sum of the series, first I need to find out the number of terms, right? So how can we find out the number of terms in AP series? Let us write down the equation where the nth term, right, that is 987 is equals to A, which is 105, plus n minus 1D, which is 14. Okay. So let us solve this. That is 987 is equals to 105 plus 14n minus 14. That is 987 minus 105 plus 14 is equals to 14n. So n is equals to, here we have got, that is 2, 8, 8 plus 14 by 14. That is n is equals to 4 to 6, 189, 896 by 14. So that is 64. So number of terms in this AP series with D14 is 64. Therefore, the summation of these n terms will be n by 2, that is 64 by 2 in the first term and the last term. So first term is 105 plus last term is 987. That is 2 ones are 2, 2 3s are 6, 2 2s are 4 is equals to 32 into 7 and 5 is 12, 8 1 9 and 9 1 10. So this can be actually written as, let us check the form options for this, that how can I write it down. So that is okay. So instead of taking, as I can see in terms of 6 we have, so instead of making it 36, what can we do? Let us say we still have 64 by 2. Okay, wait. So this is 64 by 2. So this is 64 by 2 into this. That is 64 into, so 2 1s are 2, 2 5s are 10, 2 4s are 8, and 2 6s are 12. So that is 64 into 546 is the answer. So that is basically our option C, right? So because I could have actually taken the lowest term for 64 by 2 is equal to 32, but we have to also go through according to the options. In our options, we can see clearly that there is nothing like 32 it's all in terms of 60s. So that means we have to keep the number of terms as it is, but we can take the lowest term of the bracket forms, right? So that is why I've changed the answer. Otherwise, previously the calculated answer was also correct, but we have to mark the correct option. So that is why we have to take care of that. That is, keep in mind about the options while solving the questions, okay? Now let's move on to the 12th question. Now 12th question reads, let n is equals to A, B, C, D. So there are 9A and 3 different terms B, C, D, forming a 12-digit number which is divisible by 45, where A is not equals to 0, A, B, C, and D are not necessarily distinct. That means numbers can be repeated. So how many such numbers are possible? Okay. So first of all, if I need a number, 12-digit number, which is divisible by 45, that means it should be divisible by 5 or 9 both. Now for a number to be divisible by 5, it should end with 0 or 5, right? And for a number to end with 9, divisible by 9, it should end with what? It should end with 1 and 9. Okay, any of these sometimes is divisible by 9. Okay, so this is okay, but what we need to find out here first is about the sum of the numbers, right? Because I'm going to find out how many such numbers are possible. So I have to make the summation. So since there are 9A, so obviously I can write it down as this, that is 9A plus B plus C plus D, correct? Because there are, whatever be the value of A, it is multiple of 9 because there are 9A. But remaining numbers, that is B, C, D, they are going to be any one number. So this is how we have to form. So first we have to read the question very carefully. Now another thing is this B, C, D, A, this can be repeated, right? So now we have to talk about B, C, and D. So here, let's write down. So what we have just written is the number of 12 digits can be written as 9A plus B plus C plus D, right? Now we know that this is multiple of 9. So this should be multiple of 9 so that it is divisible by 45. So that means we need B plus C plus D is equals to multiple of 9, right? Now, A can have possibly 9 numbers. Whatever you multiply it with, it is multiplied by 9. So it will always be divisible by 9. So A can be written by 9 times, right? So I have to find out the combination of BCD. How many combinations are there for this BCD? So now let us take first case when D is equals to 0, right? So if D is equals to 0, then B plus C is equals to 9K. Now, what are the different values we can put here? That is, I can put K is equals to 0, K is equals to 1, and K is equals to 2. For it to become what? 0, 9, and 18. That means we have B plus C is equals to 0, B plus C is equals to 9, and B plus C is equals to 18. Correct? So what are the combinations for B and C? So this addition of these two numbers so that I will get 0 is only one combination, that is the value of B and C should be 0. So only one possibility. Now this combination says that B plus C is equals to 9. So what are the combinations? 0, 9, 1, 8, 2, 6, 3, sorry, not 2, 6, 2, 7, 3, 6, 4, 5, right? So 1, 2, 3, 4, 5, and obviously 9, 0, right? And so on. So how many combinations here are possible? So 1, 2, 3, 4, 5, and again we are reversing it. So 5 and 5, so that is there will be 10 combinations. And what about 18? So obviously it is 9 plus 9. So the combinations here is 1. So how many total combinations here are possible? That is 1, 1, 2, and here 11 plus 1, 12. So 12. That means the total here will be 9 into 12 is equals to 108. So for A is equals to 9 values of 9 digits with that is multiple of 9, and D is equals to 0, such that the whole number, the whole 12 digit number is divisible by 45. There are 108 possibilities. Now another possibility of the 12 digit number divisible by 45 is when A is still, there are 9 possibilities of A from 1 to 9, which is divisible by 9 because this is 9A. but d is equals to 5, as then also it will be divisible by 45. So that let is our second case. For second case also we have 9 9a possibilities, and d should be 5, right? That's so that the equation is b plus c plus d is equals to, we know, 9k, so that it is multiple of 9, and b plus c plus 5 is equals to 9k. So b plus c is equals to 9k minus 5. This is the equation. Now value of k we are going to put so that it is divisible by 9 is 0, 1 and 2. So the equation will be, first is b plus c is equals to 9 zeros are 0 minus 5, not possible. So from 1, 9 ones are 9 minus 5, so 4. Another one is b plus c is equals to 18 minus 5, that is 30. So these are the two combinations. So for this combination, how many are possible, right? So let's check. Here we have b and c, so 0, 4, 1, 3, 2, 2. And reverse it. So these are 3 plus 3, so that is 6 possibilities. And here we have 13, right? So we'll start with 6, 7, 5, 8. Anything else? Right? 6, 7, 5, 8, 4, 9. So 7, 8, 9 is done. Right. So here how many possibilities are there? Similarly, 2 more possibilities are here. That is your 9, 4, 8, 5 and 7, 6. So total possibilities are 1, 2, 3, 4, 5. That means how many total possibilities now? Then in this case, 9 into 11 is equals to 99. So in the first case, there were 108 possibilities. In the second case, divisible by 45, there are 99 possibilities. So total number of possibilities that is divisible by 45 for this form of 12-digit number is 9, 9, 18, 17, 1, 10, 207. So the answer is 207. So the correct option is